Hi everyone. Now in this video I am going to explain about the equilibrium of the forces and when a bodies are connected like they are connected with a wire or string and they are arranged side by side, how these forces are affecting and how the acceleration of the system is there, that I am going to explain now. Equilibrium. When net force acting on the body is 0, we can say that body is in equilibrium. Here equilibrium is nothing but a body may not be always like at rest. It may move with constant velocity also. You see here, I am taking a body of mass m. I am applying 10 Newton force and 10 Newton force. Okay, already body is at rest. Now let us consider there is a body of mass m is there, which is moving with v is equal to 10 meter per second. Now I am applying from at the same time I am applying the forces like a 10 Newton force and a 10 Newton force. It will continue to move with the same speed. Same speed, 10 meter per second towards right side. It indicates that equilibrium is nothing but when a body is in equilibrium, it may be at rest or it may move with constant velocity. Same point I am writing. It may be at rest or it may move with constant velocity. Okay, but acceleration is how much? 0. Net acceleration is 0. Okay, now see, when a body is in equilibrium, you can write summation of f of x is equal to 0, nothing but m into summation of ax is equal to 0. Similarly, summation of fy is equal to 0. I can write the fy value is equal to 0. We can write m into ay value is 0. Similarly, summation of fz is equal to 0. We can write summation of m into az value is 0. This point we have to keep in our mind when a body is in equilibrium. For example, I will give some situations where the body is at rest. Okay, I am giving the simple example. You observe this carefully. There is a 10 kg body. For this body, here you can see weight of the body is acting downward direction 100. Normal reaction is going up. We can see here normal reaction upward force is equal to downward force 100. That's all. Okay. Now if I take the one more case, there is a string connected to a block of mass 5 kg. As the system is at rest, you can see that whatever tension in the string is there, that will be, you can write it as weight of the body 50 newtons. So you can write T is equal to here 50 newtons. T is equal to how much? 50 newtons. Okay. Similarly, if I take the any bodies like this, like 1 kg body is kept here, so it is placed on a 2 kg body. Now you can see as system is at rest, we can see here there is a one contact is there and here second contact is there. How the forces will be acting here? The second body is actually pushing the entire weight. Okay, it is pushing like this. N2 is upward direction. Total weight of the body is 30. Okay, so you can write N2 value is equal to how much? 30 newtons. Similarly, if I take the only 1 kg body Here whatever contact is there, that contact is N1 is there now, that is only pushing the 1 kg body weight. So you can write it as N1 value is equal to 10 Newton. Okay, the same manner if I take the number of blocks like one upon the other, if it is kept like a 1 kg body here, and it is placed over the 2 kg body, 2 kg body is placed over the 4 kg body. Now if I want to calculate the normal forces at different location, now I can see that first contact, second contact, third contact. So third contact. Now you can see third contact is there, no? That third contact is pushing all the forces. You can see what are the all forces. 7 kg body is there. This is my N3. Okay, so we can say that N3 value is equal to much 70 newtons. It is pushing all the force, all the weights. Whatever contact is there, N2 is there, no? That contact point N2, that is pushing the 3 kg body. 2 kg plus 1 kg. So we can say that 30 newtons. So we can write N2 value is equal to 30. Similarly, 1 kg body is pushing only 1 kg body only. Understand that? So we can say that whatever contact is there between 1 kg and 2 kg, that is pushing only 1 kg body weight. So we can write the N1 value is equal to much 10 newtons. Okay, like this we can observe whenever the bodies are placed side by side. Okay, now similarly let us consider a situation like this. I am taking a condition. A body is connected and placed, mass m. Now if you want to calculate the relations here, just consider the value is equal to 60 degrees. Now T1 is this, T2 is this. Let us consider the 10 kg. Now I can write the value is 100 Newton downward direction. Tension T3 is like this. Now if I want to write the values here, T3 value is equal to 100 Newton at equilibrium. In equilibrium case I am writing. Next, if I take a point, it is a massless point. T1 is like this, and T2, this you take like a T2, T2 like this, and T1 upward direction. Now we can see how these angles are there, 60 degrees, and downward direction we can write the T3. Already I got the T3 value is 100. You can see T1 into sine 60 degrees, T1 into cos 60 degrees. From this I can write it as T1 into root 3 by 2 is equal to 100. So I can write T1 by 2 is equal to 100 divided by the root 3. Actually you can write 200 by T1 value is equal to 200 by root 3. 200 divided by the root 3 Newton. Similarly, I can write it as T1 cos 60 degrees is equal to T2. T1 value I know that 200 divided by the root 3 into 1 by 2 is equal to T2. I can get the value of T2 is equal to 100 divided by the root 3. So by this way you can calculate the T1 value and the T2 value as well as T3 value. Okay, observe this carefully how these equilibrium forces are there. Similarly, if I take any body having mass m or any point is located here, on this I am exerting a force of 100 Newton one side, and I am exerting a 50 Newton other side. I am exerting a force of again 50 Newton like this, and making angles like a 30 degrees one side and 60 degrees other side, and making like one more force I am taking. There is a F force is acting, which is making angle 60 degrees. If you want to calculate force F, how to calculate the force F? You resolve all the component of the forces. If you resolve all the forces and equate the forces, if you equate all the forces, you can get the value of this. As per the situation, you can write summation of Fx is equal to 0. If summation of Fx is 0, what forces are there? 100. The component of 50 along x-axis is equal to 50 cos 30 degrees. Okay, and you can see one more force is there which is acting left side, minus 50 into cos 60 degrees, and one more force is there, F is there, so that we can write it as plus F into sine 60 degrees is equal to 0. Okay, from this we can get the value of is how much, 100 plus 50 means 25 root 3 minus 25 plus root 3 into F divided by the 2 is equal to 0. From this we can calculate the what is the F value if body is at rest. Similarly you can calculate along the y-axis direction also. You can calculate as per the situation. You can write the all the forces acting on the body. If body is at rest, everywhere it should be at rest only. Okay. Next one, in the same case, if you want, you can calculate the equilibrium forces and any other values also. Okay. Next one, connected bodies. Connected bodies. For connected bodies, we can see that when number of bodies are connected, they move together. Usually blocks connected to strings will move with the same velocity. Same velocity or acceleration. Force is applied, same acceleration they will move. Okay. Similarly, blocks are contact each other, they move together. Okay. When force is applied, the contact bodies move together. Okay, example you can see it. I am taking like a body of 1 kg body, 2 kg body, 3 kg body. I have arranged like this, and whole arrangement is moving left side with a force of let us consider that 60 Newton I am applying. Now you can see whatever acceleration in 1 kg body, the same acceleration will be there in 2 kg body also, same acceleration in 3 kg body also. In this case, we can see they are moving together. Now net pulling force, whatever acceleration is there, we can write it as a net pulling force divided by the total mass. Here net pulling force is 60 Newton, total mass is 6. So you can get the 10 meter per second square. This is my acceleration. Now at the same time, you can see the tension in the first 1 kg and 2 kg body is T1, and the tension between the 2 kg and 3 kg body is T2. Now you can observe that the T1 is pulling the two bodies. What bodies it is pulling here? 2 kg body and 3 kg body is pulled by the T1, and the whole system 2 kg and 3 kg moving with the acceleration of 10 meter per second square. If they are moving with 10 meter per second square, I can write the T1 net pulling forces. T1 is equal to total mass 2 plus 3 into 10 I can write. So I will get the 50 newtons. Similarly, if I take the only T2 value, so T2 means whatever tension between the 2 kg and 3 kg is there now, that string, whatever tension is there, that T2 is pulling only 3 kg body. So you can say that what is the acceleration here? 10 meter per second square. From this I can get the T2 value is equal to 3 into A, that is 30 newtons. We can observe T1, T2 values we can calculate like this. Okay. Similarly, if I take any body like this, let us consider the 100 kg body. It is connected to a massive string. Here 50 kg body is there. Let us consider that middle body is actually 10 kg rod is there, which is having length of 2 meters. which is having length of 2 meters, or otherwise you can take the, for our convenient, 10 meters I am taking. Okay, massive string. I have applied a force. F is equal to, let us consider that total how much is it? 100, 150, 160 is there. So if it is 160, I am taking like a 320. Okay, 160 is it, so 3200 force I am applying here. Newton force is applying. Now if I want to calculate the at a different point, tension at point A, tension at point B, tension at point C. How to calculate tension at all this? First we can see that the whole system is pulled by the 3200 Newton, and again we can see downward direction 100 plus 10 plus 50, whole thing into 10 is weight. So you can write 150, 160, 1600 Newton is downward direction. As a whole, A will be going up. Again I will write the A is equal to net pulling force divided by the total mass. If I write the net pulling force is 3200 minus 1600 whole divided by the total mass is 16. So I will get like a 1600 by 16. I will get the value is 100 meter per second square is my acceleration. If I know that, we can see the A point is only pulling 50 kg body. Now B point is pulling only half of the string and 50 kg. C body is pulling remaining things. I am drawing same thing here in next page I will write now. You can see whatever the A is there, tension at point A, it is pulling. So A is equal to 100 meter per second square. TA value is equal to how much? 50 into A. You can write as 50 into what 5000 I was getting. So you can see it is not 60, 160, sorry. You can see 10 meter per second square is the value. Total mass is equal to 160. Okay, 10 meter per second square is there. You can get the value of acceleration value is how much here? 10 meter per second. So we can write 500 is a TA. TA value is this. Similarly, if you see that TB value, TB is pulling like a 50 kg and half of the string. Half of the string is what here? 5 kg. Now we can see this is the TB. Now TB value, and one more thing, TA value I wrote wrong. Now you can see downward direction also force is acting now. 500 Newton is acting. We can see net pulling force is we can write it as TA minus 500, upward force minus downward force. We can write it as TA minus 500. That value is equal to mass into acceleration. Okay, that we can write it as mass into acceleration value is equal to 50 into A is equal to TA minus 500. Now we can write 500 50 into I is equal to this TA minus 500. We can see TA value is equal to 1000 newtons will be there. Similarly, here we can see that net downward force is how much? 550 value will be there. Upward direction A is there. Now we can say whatever the A value is there, 10 meter per second square. Now you apply that. So we can write the net pulling force is upward force is TB, downward force is 550. As it is going upward direction, we can write the total mass is 55 into 10 MA, value is equal to TB minus 550. So we can get the TB value is equal to 550 plus 550, we will get the 1100 Newton we will get. Similarly, if I take the third mass, like this is 50 kg, and we can see that 10 kg string is there, and point C is acting upward direction. Downward direction, entire weight is there now, that 600 will be acting downward direction. A is equal to 10 meter per second square. We can write that TC minus 600 is equal to 60 into acceleration A. So TC is equal to 600 plus 600, you can get the 1200 Newton will be acting on TC. Means force acting on this TC, force acting on this 10 kg body plus 50 kg body is 1200 Newton. This is a tension at different locations. You can observe that how to calculate the tension for the massive string. Similarly, sometimes they may ask like this also. There is a massive string, a force F is applied. If you want to calculate the what is the tension at x distance from front end, find tension at x. Okay, now mass is m, length is l. Now we are going to calculate as a whole system is moving forward direction with the same acceleration a. First I will let a is equal to force F divided by the total mass m. But we can see that remaining part of the length is L minus x. What is the mass of this? Mass can be written as its linear mass density into its length L minus x. What is the linear mass density? M by L into L minus x. Okay. And tension T is acting and the body is going like this. I can write the T is equal to m dash into acceleration a. What is my m dash? M by L into L minus x into, and we can write the a value is equal to F divided by the m. If I see, if I just observe this, m and m get cancelled. Finally, I can write the F into L minus x divided by the L. This is my tension at the x distance. Okay, here lambda is linear mass density. Lambda is mass by unit length. Mass by length, m divided by the L. This is a linear mass density. Okay. Similarly, if I take the connected bodies like this, let us consider that here 10 kg body is there, and here 5 kg body. We can take the let us consider the value is 3 kg body. All three are placed like this. I have applied a force of let us consider that it is how much? 15, 18. So I am applying 36 Newton. I am applying. Now you can see contact. Where are the contacts are there? Here one contact, second contact. First contact between the 3 kg and 5 kg. Second contact between the 5 kg and 10 kg. Now we can observe that all these three bodies are moving together with the same acceleration. I can write A is equal to net pushing force. Net pushing force is divided by the total mass. Net pushing force value is only 36 divided by the total mass is 18. So I can get the 2 meter per second square is my acceleration of the system. Now you see here, whatever the contact is there between 1 kg, 5 kg and you can see 5 kg and 10 kg. This 5 kg and 10 kg bodies are there here. Whatever contact is there between the 3 kg and 5 kg is there, no, that is N1 I am writing. This N1 is pushing the 5 kg and 10 kg as we have not directly applied on 5 kg. So A is equal to 2 meter per second square. Now I can write N1 is equal to much? 5 plus 10 into 2. I can get the 15 into 2 is 30 newtons. Okay. Similarly, you can see between 5 kg and 10 kg, whatever force is there, that is only pushing the only 10 kg body. Okay. So you can observe that only N2 is pushing the 10 kg body. That is A is equal to 2 meter per second square. Now I will get the value of N2 is equal to 10 into 2. 10 into 2 is 20 newtons. This is the contact force. Okay, like this connected bodies are there, you can calculate. Similarly, if it is spring forces are there, how spring forces will be there? Let us consider there are the two masses. I am taking like a two masses. Let us consider the small m mass and capital M mass. capital M mass. Spring constant is, let us consider the K. I have applied a force F. If I apply the force F causes, let us consider that the second body is moving with A. What is the A dash value? If that is a question mark, then how to write the relation here? As the spring force is changing the shape of the spring, both the blocks will have different acceleration. As spring is elongating, both connected bodies will have different accelerations. They will have different accelerations. How they will have different accelerations? We can see here. First, already M body is there, and here spring force will be acting right side. Moving with acceleration A, we can write F spring can be written as mass M into acceleration A. Similarly, if I take the capital M block, on capital M block there is a F force, left side there is a spring force will be acting. You can see here spring is acting, force is like this, and the other body is left side it will act. Okay, now we can see direction of this is A dash. So F minus F spring is equal to capital M into A dash. F minus F spring is small m a, M into A dash. So I can write A dash value is equal to F minus ma divided by the capital M. This is my acceleration of the system. Okay, acceleration of the second block you can calculate. Acceleration of second block you can calculate like this. Okay, by this way you can calculate the different forces. Suppose string cut problems. String cut problems. If spring is cutting, let us consider the, I will take one of the question. Spring is 2m and one more body is which is having mass is equal to much m. Now initially equilibrium, it is located in equilibrium. I am writing equilibrium is here, equilibrium. If it is in equilibrium, we can see that spring actually having the spring constant k. If you want, you can take that. At equilibrium, you can take that mg, and the tension is acting upward direction. Same tension will be acting downward direction, and 2mg will be acting downward direction. F spring will be acting upward direction. If I take the for 2 kg body, 2m body, I can write it as similarly for m body. So as a system is in equilibrium or at rest, we can write it as T is equal to m into g. Similarly, F spring can be written as 2mg plus T. So if you substitute this T value, I will get the F spring value is equal to much 2mg plus mg. I will get the 3mg. These are my values. Okay. Now I am string cut problems and spring cut problems. Spring also together I will explain. Spring cut problems, both I will explain now here. Suppose if string is cut, if string is cut, immediately after cutting the, what will happen? Tension in the string will be 0, but immediately after cutting the string, spring force will not change. Spring force will not change. That will be remain same. In that case, we can see that small m body is there now. That will be falling with mg. So this is the acceleration of the m body. So we can write acceleration of m is equal to much mg divided by the m. We can write it as g downward direction. Now same manner, if you take the 2m block, the forces acting is F spring is upward direction, T is acting downward direction, 2mg is acting downward direction. as string is cut, this value is not there. Overall we can say if spring value is upward direction 3 mg is a block of mass 2 m will go upward direction. Okay, so we can say that 3 mg minus 2 mg is equal to 2 m into a 2 m. So finally we'll get the acceleration of the 2m block is equal to mg divided by the 2, that is g by 2, upward direction it will move. Now if spring is cut, if spring is cut, I am cutting the spring, then spring force will be 0. Spring force will be 0, but string force will change. Spring is same, but string is nothing but tension, T change.